We're talking about the rate and application. So here we're going to start off with the percentage formula. And if you're talking without permission, like I've given you a couple chances, so now I'm going to go straight to, you see me after class, we'll figure it out. Okay, but percentage equals rate times base. So remember that formula? We got that on the first lesson of these types of problems. But what are we trying to find in this lesson? The base. So somebody raise their hand and tell me, from this formula, how do I get B by itself? B by itself. Yes, Thalen?
Divide by the rate.
Yes, divide both sides by the rate. So you're going to divide both sides by R. And so you end up with this formula. B equals percentage over rate. That is your formula. And I'll even put that in here, because some of the problems are going to ask you use a formula. Some of them will say use the proportion. Yeah, so if you guys can figure this out, that's great. And that'll help you out because it gives you another way of doing it. Okay, that's your formula. The base, or the whole, is equal to the part divided by the rate. Okay, but there is also a proportional way of doing it. So does anyone remember? This one's a little harder, but using the letters P, R, and B, what does my proportion always look like? Using those three letters plus the number 100, because that goes in there too. Okay, Caden?
R over 100.
So R over 100, that's always in there.
And P over B.
Yeah, the percentage, the part over the base. Good. Or the part over the whole. All right, that's your proportion. And this one's always been the same, so that's nice. Sometimes they'll ask you to use a proportion, so use that.
And Mr. Allen, so the thing that says percent over 100 equals is the percentage?
Yeah, is the percentage or the part, and base is the whole or the of number. Yeah, so they're all the same. They all mean the same thing. Ma'am?
For formula, that the B equals P over R, is that only for the base?
That's yeah, for the base.
And then the top one is for percentage.
And do you remember what the rates was?
R equals P over B.
P over B, yeah. And if you just memorize one of them, you actually can figure out the other ones, but there are separate ways of writing it. Okay, let's read, because you're like, what in the world is this talking about? Let's read the example on page 224 to get us some context into what's happening here. In fact, let me give you extra context. So hold on, ladies. When I taught chemistry, I had to mix up chemicals to let the kids use them for their experiments. So I had pure acid in a bottle. I don't give you pure acid for any experiment, because if I gave you pure acid and you spill it on yourself, splatter some of it, or dump it on accident, someone's going to get hurt badly, okay? But I have to make your solutions before class starts. Look at this 2% acetic or acetic solution, and then this 1390 milliliters of acetic acid. Okay, I'm going to tell you a little bit more about those, but let's read the problem now. Who can volunteer? Okay, I'll let Jimbo do it.
So it's at the top.
Yep.
Heather is helping her chemistry teacher prepare solutions for next semester's lab course. One solution calls for 2% acetic acid. If 1,390 milliliters of acetic acid is available, how much solution can be prepared?
Okay, so they're not asking for how much acid they have. It already tells you 1390 milliliters of acetic acid. They're asking you how much solution can she make out of that acid amount. But what is the solution going to be? 2% acetic or acetic solution. Okay, what I was doing when I was a chemistry teacher is I would mix these up, and I wasn't very good at, it's my first year doing it by myself. So I get the acid that I needed, and I get the water or whatever I need to mix it in, and I'm thinking, oh, you just measure it out, pour it in, should be fine. I had an acid and I think a base, and I had to pour them together. I don't know if you know what happens when acids and bases get mixed together. Salt and water with something else. So I pour in the base, and I had the acid, pour it in. As I'm pouring it in, boom, smoke, and Mr. A being frightened because I didn't know that was going to happen. Do you know what happens when you mix acid and a base? You get salt and water, right? But what else comes with it?
An explosion.
Explosion. Heat comes out.
Superheats the water into steam, which explodes.
Yeah, so when I touch the container after putting on gloves, goggles, and maybe a hairnet or two, I touch it, it's hot because there is a reaction that went on.
And then you
So if I gave you just pure acetic acid, so that's not that much, it's like half a 2 liter, a little over half a 2 liter. If I gave you that, guys, I'm going to get a lawsuit. I'm going to stop teaching because they're going to fire me, and I'll probably never handle chemicals again because that's too dangerous for you guys to handle in a class. So what I want you guys to know is this is what's going on in this solution. So for example, if you had 100, you don't have to draw this out, but if you had 100 milliliters of water, of a solution, and that's even too much, 2%. So 100 milliliters of liquid, 2% of it is the acid. That's enough for the experiment. So do you need a lot of acid in the container? No, that's bad. If this was all acid, the container's probably fizzling out and stuff anyway. Okay, anyway, so that's what we're dealing with. Just a little bit of acid in the whole solution. So how are we going to find out how much solution we can make? We're going to use, first of all, the formula. So I'm going to use the formula, and then we'll do it with the proportion as well. Okay, here we go. The base is equal to, do you guys remember? It's on the last slide. Percentage over rate. Okay, what's the percentage in this problem? Yes, Tyler?
It's
It's a 50-50 here. Percentage.
unknown.
No.
The base is unknown.
Okay, so the percentage is 1,390.
1,390. Yep. What's the rate, therefore? 2%. Remember, a rate is always a percent. So then I have 1,390 divided by 2%. Do you just divide 1,390 by 2?
No.
No, I have to. 1, 2. So I get this problem, 1,390 divided by 0.02. That's my division problem. Because you don't remember when you have a percent in the work, you have to make it a decimal or a fraction to actually work it out. Okay, so here's the division problem. 1,390 goes in the box and 0.02 goes outside the box. But do you just divide it the way it is?
No, you have to
Move it twice again, add a couple zeros. And here's what I do for myself, and I'll help you out as well. I put commas in this number because I want to make sure I get the place value right. You know, in the last class I felt bad on the last problem. Remember your homework? 35% was the answer. Someone got 3.5%. I mean, they did the math right, except what was the only mistake they made? The decimal place. Imagine doing this work, and you have the right digits in the wrong spots. Wouldn't that be kind of discouraging? Can you do this? Would it be kind of just you did it all right, but you moved the decimal too many times, or you didn't put it in the right spot? So please be careful. All right, I'm going to do short division here. 2 goes into 13, 6 times with the remainder of 1. 2 goes into 19, 9 times with the remainder of 1. 2 goes into 10, 5 times, and then I have 0, 0. So I got to fill in those spots. So 69,500 milliliters of solution. So that's how much she's going to use for that semester's course. Using this much acid, she's going to make that much solution. Okay, now, does my answer make sense, though? Because I'm looking at it saying, wait, what? Somebody, yes or no?
I don't know.
How many of you say yes, it does? How many say no, it doesn't?
I don't know.
Okay, so how many say yes? How many say no? Okay, like this table right here and that table, they're split. One says yes, one says no. Do you guys want to explain your answer? Why does it not make sense? Why it does make sense? Anyone?
It just
Hold on, one of you, because it's hard when all of you. Go ahead, Caroline.
It's the base, and the base. It just makes sense.
just does, right? It feels good. It feels right.
Yeah,
It just looks right.
All right, let's go with Tyler.
okay.
So does it feel right or wrong?
It feels right
Yeah.
because if it was a alright, let's just say, use an example as 5 over 1. But that's a little bit more than 5 over 1. So it would be that number, since it's even less than it's
It just
really
works.
one number is way bigger and one number is way smaller. So since you're dividing things by less of not even a whole number,
Okay.
it gets bigger.
Okay. I love that. That it's hard to explain, right? Even just to come up with the words. Here's what we're gonna say.
There's no other option to.
Guys, this is the whole. This is what they're making. This is everything. And part of that whole is this amount. And you're like, isn't that way less than that?
Yes.
Yeah, it's 2% of that. Right? This number is 2% of that number. This is huge. Yeah. It's way bigger than that one. It's actually 50 times bigger than that. And we're going to see that a little bit clearer using the proportion method. All right, let's do the same problem with the proportion, and let's see maybe if we can understand it a little bit better. Okay, so I know that the rate goes over 100. What's the rate in that problem?
2%.
2%. So 2 over 100, that's 2%. Okay, where do those other numbers go? Do you have a question, Sammy, or do you know where they go?
I have a question.
Okay, hold that question real quick. Where do those numbers go, Camille?
The
Percentage and the base. What are they?
1390 goes on top of
On the top, 1390, and then we'll just say B goes on the bottom. Okay, go ahead and solve that out, but if you do something, you might help yourself out before you cross multiply. So do that real quick. So you could do it, in this case, one of two ways. If you do something to the fraction, you might make your math easier. How many can see 2 over 100 is also known as 1 over 50? All right, so now you get B times 1, which is B, and 1390 times 50. That's what I'm going to actually work out. 1390 times 50. On this same problem with the other method, I divided. And this one I'm multiplying. So how is that going to work out? All right, let's just do this math. Let's see here. 18. Whoa.
boom!
And don't forget your units, guys, when they're asking you for certain amounts. 69,500 milliliters. Okay, ready? Here we go. If this is the way to set up the proportion, let's see. Look at 1/50th. This number is 50 times smaller than that number. Do you see where the 50 comes from? Okay, so that's where I got it. That's where I got that 50 times bigger. And I hope that makes sense. Is that weird? Sometimes. But I hope you guys can handle it. All right, okay, I got another problem. Here's another problem. And it comes from page 225, example number 1. Who could read that real quick? Ruth? Example 1, page 225.
The sales taxes should be 8 1/4%. One day, a store collected $384 in tax. What were the store's total sales on that day?
Okay, so are they asking you for the sales tax rate? No, they gave that to you. Are they asking for how much did they pay in taxes? No, because that's how much they collected. They're asking you how much did they sell on that day? Total sales. Okay, so here we'll go with the proportion. Okay, where do these numbers go? I know that 8 1/4% can go here on the right side or the left. It doesn't really matter, but it goes right here. 8 1/4 over 100. And then where does that 384 go? Because that matters. And if you put it in the wrong spot, well, then you get a bad answer. Yep.
384 goes on the top because it's the part.
It's the part. So 384 is the part. I don't know the whole. Because the whole is how much they sold that day. And the part is how much how much in taxes they collected that day. So go ahead and work that out. What do you do with 8 1/4 to help you out?
Change it.
You could do a decimal. I think most of you are going to do decimal. What's 8 1/4? Sorry.
8.5.
8.25. All right, so we'll just do that. It's not necessary, but most of you like your decimals. This is a harder problem, as in the division is a little bit more involved, but I'm going to do it with you. This is going to be my third time today I do this tough problem. So
Third. Oh, because you did.
I do it on my own. I do it with the other class. I do it with you. So 3 times.
Why would you do it on your own?
Because I want to see how it works. Like, does it work well? How can I explain it? How can I prepare Sammy for it? Do you see how I prepare by saying, it's going to be hard, so work through it. Yes, and Jimbo and Henry and Colin and Dalen and Reese, yep, and Camille. And then, and then Ruth too, yes, of course. Can't forget Ruth. I get this. 8.25b equals 38,400. All right, but what do I have to divide both sides by?
8.25. 8.25, and then you divide, you make the decimal twice.
Yeah, so here, okay, here's the problem.
3,000,000?
38400 divided by, I'm going to move this over a little bit. Stay over there. 8.25, but I have to move the decimal twice, which means I have to add a couple zeros. You can end at the decimal point, so you can end right there. Okay, I'm going to do this because I want to know my place values. Does 825 go into 3?
No.
38.
No.
384.
No.
3,840.
Yes. Yes.
Okay.
4 times.
Okay, so here's what I'm going to do. I heard 4, so 825 times 4. I get 3,300. Which, yes, it means it won't go anymore, so I'll put 4 right there. 3,300. Then I'll subtract 540, bring down a 0. Okay, now when you're dividing, especially bigger numbers, you see this work right here with this multiplication? Don't erase it. Why would you erase your work? You might have to do it again. So just leave it there. Okay, how many times do you think 825 into 54?
6 times.
Okay, I'm going to go with 6. 825 times 6. So 30, 15, 48, 49. Oh, so 6 times is it? 6 times, that's 4950. If you did 5 and you worked it out here, it wasn't in vain. It wasn't like, oh, so you mean I could have just done by 6 and I did it by 5. Okay, you actually helped yourself out if you keep it up there. Okay, so here we'll subtract again. And then bring down another 0. What do you think?
5.
You know it's not 6, right? And it could be a little bit over 4, so try 5. All right, you still have to multiply it, so 825 times 5. Oh, they made it. So 5 goes into that, or it goes into it 5 times, so 4125. Oh, but you're almost done. One more time, you're done.
So
4.
many zeros.
Okay, last time I had to bring a 0 down. Oh man, I gotta see how many times. I don't know, like 7?
4.
Well, how do you know?
Because
You-
up there,
You already did it. You already did it. It's 4 times. And you're done there. You're done with this problem. Just keep it, cut it off so you don't have to keep going on and on. But what's my final answer?
4,654.
Oh, I was going to say 46.
Dollars. Dollars.
It makes dollars.
No dollar, because the decimal point's right here.
That would just make $46. You don't need. There's that decimal.
Oh, sorry. I moved it twice already and made those. Okay, hold on. Do the units matter? I've asked this before many times for many years, many students. And people say, hopefully yes. But I was tutoring someone today, this morning, and I was like, hey, do units matter? He's like, yeah, just like that.
What?
I'm like, I think they matter. And now when I asked him the next questions, which I will ask you guys, he kind of tried to get away from it, but I'm going to see if I can get it from you guys. All right, ready, Cole? It's for you, buddy. you want 3 of them? Yes or no? No. Okay, $300. I'm sorry, you don't get them. But Cole, listen, that was kind of mean. I'm going to give him a second chance. Do you want 3 of them?
No.
He's still, okay, you heard it yourself. He does not want $300.
I want 300.
Third chance, ready? Do you want 3 of them?
No.
Yes.
Oh my goodness, this $300, you say no to him? What is this guy's problem? Okay, so Cole, really? Really, buddy? Stella, do you want 3 of them?
3 of what?
3 of them, yes or no?
3 of what? So yes.
I say yes.
All right, Caroline, awesome. You all 3 homework assignments for Caroline. She said it herself. Okay, what's the problem with this? I am not giving you any units. Tyler, 3 of them?
Mr. A, you triggered me. Baby.
Yes or no?
If you get it first.
Or.
Hey, that's
Alright, that was
No, yes or no? No, or is not an option.
yes. No.
Yes, no.
Do no reverse call.
Yes, no.
Yes.
Got it.
Same answer. You
Space.
either
Yes.
Yes,
either
no.
get 300,
Oh.
3 homework assignments, or nothing. No one get 300.
Okay, we'll do this problem. Let's look at, so here I set up a proportion on this problem, but I got it from example number 2. Units matter, guys, so I'm marking them wrong if you don't give me units. Just give me the units. I want to know what they are, because it matters.
Oh wait, Mr. A.
Caden, read for me example number 2, Mrs. Graham.
Mrs. Graham receives 2.5% commission on her total sales at Colony Furniture. In order to earn $300 in commission, what would her total sales have to be?
Okay, so here what it's saying, guys, is that she gets 2.5% commission, 2.5%, and she wants to earn $300 in now, notice she works for a furniture company. Could she have been the one who sold us these tables? I don't know. But the fact is this, she wants to make $300, so how much does she have to sell? How much money does she have to sell in order to get that? So here's where I got my 2.5 over 100. The part is 300. That's her commission amount. So how much is her total sales right here? So the B. So go ahead and find that out. You can do anything you want with that 2.5 to make it easier for you. I'll show you what I'll do in just a moment. I hope you multiply by 100.
Is the unit dollars?
Good question. So looking at the problem, it says, what would her total sales have to be?
Couldn't you make it?
So what's your determination? You can look through it. I want you to figure it out. Sorry, B.
Easier to make it a decimal.
No, not for me, but maybe for you. Go ahead and do it. All right. I'm going to leave it as a fraction. You could do it as decimal. It's your choice. So I'll put 30,000 equals 5 halves B. Then I multiply by 2 fifths. The 5 cancels out with that.
Yes, I got that answer.
$12,000. So listen, if she wants to make $300 for herself in commission, she has to sell $12,000
Which is
worth
not
of.
hard. She could just sell like 3 cabinets. Expensive.
Yes, and so that's how you work it out.
I did it.
I did.
How dare you?
Okay, hold on, guys. I do have your assignment. It should be the same as the other class if you can handle that. I want to work out a couple problems with you just to get you going, but you got to give me that quiet so I can help you out. Ma'am?
So I got 120,000. You could come and look at what I did.
Yes, I'll look at it. Go ahead and start that up. That's number 2. I'm going to help you with that one once you guys are ready. Okay.
Failed this. So I simplified it. I turned that into a decimal and then simplified it, and then divided them both by 5.
Oh, okay. That's so...
And then
So you did that times that is 6,000
And then
divided by 0.5.
and then you add a 0 on the end.
Hold on.
I think I did one too many zeros.
Yeah, I think that's. So 6,000's right here,
Yeah.
and add one more 0. All right. If you're quiet, I can start helping you out with these because these look a little different, but they're not. Okay. On number 2 and number 4, it says use the formula. I believe it says use a formula to find the base. So what's that formula? Okay, that's for the percentage. How do you find the base?
B equals P over R.
P over R. Good. All right. In this problem, the way it's written, what is the percentage?
60%.
27. Remember, percentage.
I thought you said percent.
Yeah, and I'll use these words so that I won't confuse it. So percentage is 27. What's the rate? 60%.
60 divided by 27 or 27?
It's always top divided by bottom.
B over R.
Yeah, so percentage over 60%. And do you want to just use 60% the way it is?
No, you have to move
1.6.
So it's 0.6. So just go ahead. I'm not going to work it out with you. I want you to work it out, but it's 27 divided by 0.6.
Oh,
If this is your part and it represents 60%, that's a part, your whole should be greater than 27. It's kind of like saying you got a 60% on this test, and I know that's a little bit low, but 60% of the test, that means you got 27 points right. 27 points right. So how much was the test worth is what I'm asking.
do we have to do it using the formula? Can we use the
Yeah, for these first two, do the formula, and then for the rest of them, you can do proportion.
I think I'm good for A. You just crushed my heart.
Ooh.
And she's still smiling about it, so I'm good with it.
No, I'm not.
Sorry?
No, I'm not.
Yeah, I'm sorry. Yeah, you're still smiling. She must like it then.
Are there any
Yes.
I need paper for my homework.
Can you ask somebody? Does someone have an extra piece of paper? Nicole? Thank you.
No units.
Yeah, there are no units in this problem, so that's okay.
I got 25.
All right, I can't say. I'll let you guys grade it. I'm not going to say. Sorry.
Wait, do we have to put percent on the end of that one?
You tell me.
I do.
What?
Wait, what page?
So did they already give you a percent?
Oh, yeah.
So I don't give them a percent back.
For the next one, could I write 333?
Okay, here's the formula. I'm trying to help you with this one, guys, because this one gets trickier, especially with that 33 1/3 percent. Okay, what is the percentage on this problem? Percentage. And therefore the rate is 33 1/3 percent.
Could I change it to 333 since you have to move the decimal? If I change it to 33.
So here's the problem with that. I mean, you will have to move the decimal if you want to go that route, but you still have a decimal fraction, which is like, okay, 33 1/3 percent. 33 1/3 percent is equal to what? Hold on. Is equal to what fraction? And it's okay. Fraction. That means this number I want you to give me does not have a percent in it. Jimbo?
1/3.
1/3. Thank you. 1/3.
Wait.
If you got 1/3 of the test wrong, if you got 1/3 of a test wrong, that means you missed 33 1/3 percent of that test. So these two are the same.
A 66.
Yeah, like a 66
333.
and 2/3 percent. Correct. Yeah. So here's what I do. Watch. I'm trying to help you out to make this one easier. 54 divided by 1/3. You're like, why would you want to do that? Well, because I don't have to deal with repeating decimals or a decimal fraction. And you're like, but what do? It's 54 divided by 1/3. Stay, change, flip.
But I don't understand what happened to the third.
Well, I hope you do that.
Wait,
Like
so
without even going into one.
Because if you do 1, how many times 1 goes into 3?
You mean like that?
Yeah.
Uh huh.
Mr.
Yes, ma'am.
Why does the 33 just go bye-bye?
The 33 and 1/3%,
33.
because that is exactly equal to just 1/3. Like, and if you guys remember, yes, we have proved it. If you had 66 and 2/3%, what could you automatically change that to? Just 2/3.
Proportion time.
Is it in relation that the number, 2/3 is 0.6 repeating? Is it because it's 66?
Yeah, there's
from
one.
Because it's 6.
Yes, exactly. No units on this one. The units start coming on number 10, commission and rates. All right, guys, that's all I'm going to help you out with on these problems. You do the rest. Goodbye.